Alright guys, for number 6, we're given the following question. It says, when a plus bx times root 1 plus 4x, okay, where a and b are constants, when that's expanded in ascending powers of x, okay, it tells us that the coefficients of x and x squared respectively are 3 and negative 6. And it wants us to therefore find the values of a and b. How do we do that? Well, we've got a plus bx times the expansion, right, of one plus 4x to the power half. Okay, and if we go back to our expansion formula here, all right, if we go to our expansion formula, what we can say is, okay, what we get is a plus bx, all right, times 1 plus half 4x, okay, plus half minus 1 over 2 4x squared. Okay, continue the expansion. And if we simplify that down, what we get is a plus bx times 1 plus 2x minus 2x squared. Okay, keep adding along. And we can therefore multiply that out now. Because remember, we're trying to find a and b, right? So if we multiply this out, what we get is a plus 2ax minus 2ax squared plus bx plus 2bx squared minus 2bx cubed, okay, which results in what? We can go for, okay, a plus 2a plus bx plus 2b minus 2a x squared, right, minus 2bx cubed. Perfect. So we know that the coefficients of x here, okay, the coefficient of x is 3 and the coefficient of x squared is negative 6. Therefore, I can say 2a plus b is going to equal 3, right? And 2b minus 2a is equal to minus 6, right? Because of our x squared over here. Which means, from here, if we add the two together, we get 3b, right? Then a is going to cancel, equal to minus 3. Okay, 3 plus minus 6, negative 3. So therefore b is equal to negative 1. Right? B is equal to negative 1, so therefore 2a minus 1. Right? 2a minus 1 is therefore going to equal 3. And therefore a is equal to 2 as a result. Alright. So this is just a classic kind of example of, it's not too difficult, it's just a bit more time consuming. And you just got to refer to the equation in your formula booklet. Okay, where we got a plus bx times 1 plus and then nx. Okay, so we've got n, this is our value of x according to the formula, right? And we just plug that all in, and then we can simplify down to here, from which we can expand, factorize, and then get simultaneous equations for a and b. And we get b is equal to -1 and a is equal to 2. Okay. Alright guys, now for number 7, 7a specifically, it's given that y is equal to ln of ln x, okay? And it wants us to show that from this, that dy by dx is equal to 1 over x ln x, right? So, how do we go about doing that? Well, dy by dx, okay, knowing that y is equal to ln of ln x, it's simply just going to equal 1 over ln x. Okay, then you apply the chain rule here. It's ln of ln x, so 1 over ln x times dx of ln x, alright? And what's that going to give you then? Well, that's going to give you 1 over ln x times 1 over x, which equals 1 over x ln x, okay? Simple enough. That's the first bit for 7a. Alright guys, now for number b, we've got the following question. We've got a differential equation x ln x plus t times dx by dt equaling 0, okay? And it's given that x equals e when t equals 2. And knowing that, it wants us to then solve the differential equation, okay, obtaining an expression for x in terms of t, right? So how do we do that? Well, what we're going to say is x ln x, okay, plus t dx plus dt equals 0. Okay, just starting off with that. We can then say, right, we've got t dx by dt here. That's going to equal minus x ln x, right? Which therefore means that dx by dt is equal to negative x ln x, right, over t. Cool. So then, moving on from here, we can then separate the variables even more. We can say that negative 1 over x ln x dx is equal to 1 over t dt, alright? And as a result, we can now integrate, right? We can say that we've got negative integral of 1 over x ln x dx here, and that's going to equal the integral of 1 over t dt over here. Brilliant. Brilliant. Now, interestingly enough, okay, we were told in the beginning that y is equal to ln of ln x, okay? Y is equal to ln of ln x. So I can say, well, now since y is equal to ln of ln x, okay, and we know that dy by dx, right, is equal to 1 over x ln x, we can say, well, therefore, what we've got here is, if we integrate, we're going to get negative ln of ln x, right, being equal to ln t plus c. Now, why have we done that? Because, as you can see, we've integrated this and we've applied the minus to it. And over here, it's just a simple case of integrating according to our ln rules. So that's ln t. right, and adding the constant of integration. But we're not done yet. Okay, it's given that x equals e when t equals 2. Okay, so now x equals e when t is equal to 2, right? So therefore, negative ln e is going to equal ln 2 plus c, right? And what's ln e? Ln e is 1. So you go negative ln 1 is equal to ln 2 plus c, which means that c is going to give us negative ln 2. So putting this all together now, guys, what we get is therefore ln x is equal to negative ln t plus ln 2. All right? And we can therefore say that, okay, now this is a part that's going to kind of trip people up a bit, because you've got ln x, what do we do now? Well, think about it like this, right? We can say that ln x, okay, is going to equal e to negative ln t plus ln 2, right? That's going to give me e to negative ln t times by e to ln 2. All right, which means that ln x, all right, is going to give me what's going to equal I'm going to have 2, okay, and we're going to have t to the minus 1. According to our exponential rules, okay? Therefore, ln x is equal to 2 over t. So therefore, x is equal to e to the power of 2 over t. Okay? And that's going to be the final answer to that question. So just a recap on that, okay? Just a recap on this. We know this, and we've now been asked a differential equation. It wants us to find an expression for x in terms of t. Okay, so we lay out the equation. We then say, okay, we've got negative 1 over x ln x dx is equal to 1 over t dt. And we know that since y, okay, we separate the variables. And we also know that since y is equal to ln of ln x, what that implies, okay, is that this is going to turn into ln of ln x, okay, because this is dy by dx. And then we get this here, apply initial conditions, okay, cool. And then we just simplify from there. Okay, raise everything to e, we get to this, and then we apply the logarithm rules. All right. And as a result, we get 2 times t to minus 1. Okay, x equals to e to the power of 2 over t. Alright, now for number C, guys, it says, hence state what happens as the value of x, to the value of x as t tends towards infinity. So, as t tends towards infinity, what happens? Well, as t tends towards infinity, right, 2 over t is going to tend towards 0. Okay, why? Because t is increasing, t is the denominator, so the whole thing goes towards 0. Simple enough. And so what we can then say is that the limit as t approaches infinity, okay, of e to 2 over t, well, that's just going to equal e to the 0 then, because this is true. All right, so e to the 0, therefore the value of x, okay, the value of x equals e to the power of 2 over t is going to just tend towards 1. Alright guys, now for number 8 we've got the following question. The constant a, right, is such that the integral of ln x over root x dx between 1 and a is equal to 6, okay? And it wants us to show that a is equal to e to the power of 1 over root a plus 2, okay? So, the way we go about doing this, okay, is we're going to say this. Let u equal ln x, right? If u equals ln x, we can therefore say that du is 1 over x dx. Okay, and what I'm also going to say here is, so we're not really doing this via integration by substitution. We are kind of, but not in the way you'd think. Okay, so what I'm going to say here is x, let x equal e to the u. Alright. So, with that in mind, okay, that's basically saying the same thing here. I can therefore say, well, if du is equal to 1 over x dx, I can therefore say that du is equal to 1 over e to the u dx. Okay, brilliant. So therefore, e to the u du is equal to dx, right? So, if we integrate between 1 to a of ln x over root x dx, we can say that according to our new parameters, we've now got ln a at the top, we've got 0 at the bottom. Okay, because x equals 1, therefore u must be equal to 0, and we can then say fine, that's equals to u e to the u over e over u to u over 2 du, which is therefore going to equal ln a at the top, 0 in the bottom, right, u e u over 2 du. Okay, perfect. Now we can do integration by parts. Okay, I'm going to do integration by parts. When we do integration by parts here, what I can say is let u equal u, let dv by du equal to e to the u over 2. Okay, so u equals u, dv by du equal to e to the u over 2, right? So therefore, the implication there is that v is going to equal 2e u over 2. Okay, so now we've just made this whole process 1,000 times easier for ourselves, right? Because now I can say that the integral of ln a at the top, 0, ue u over 2 du, okay, is equal to uv, so 2 UE u over 2. Right, integrating between ln a and 0. Okay, I'm in this graph. Ln a at the top, 0 in the bottom, 2e u over 2 du. Okay, perfect, because v du. Okay, so we've made this way easier for ourselves, because now what we've got is, we can say 2 ln a e, right, 2 ln a e to ln a over 2 minus 0. Okay, minus, and that's what this represents, minus minus 4 e u over 2. And that's going to be integrated between ln a, between 0 and ln a. Okay, so you integrate this. Okay, it's 2e u over 2 divided by half. Okay, so you get the 4 there. Cool. All right, so you can then say, all right, well, if we simplify this down, we get 2 ln a to the half minus 4 a to the half minus 1. Okay, 4 a to the half minus 1, which we can then simplify further. We can say it's going to equal a to the half 2 ln a minus 4 plus 4. Okay, if we factorize this, right? So I'm going a bit quick, but if we expand and we factorize, that's what we'll get. Okay. All right. So the next bit is we can say that, okay, we found the integral. How much space we got? We found the integral. The next step is to plug in. Okay, so if we plug in now, we get 8 to the half, 2 ln a plus 4 plus 4, that equals 6. Okay, which means then, okay, if we take this down, we get 8 to the half 2 ln a plus 4, okay, is equal to 2. Right, so we get what? We get 2 ln a, 2 ln a, so that should be minus 4 over here. It's quite a tricky question. Right, so we get 2 ln a minus 4 is equal to 2 over root a. Right, which means then that ln a minus 2 is equal to 1 over root a, right, which gives me ln a is equal to 1 over root a plus 2, right? Ln a is equal to 1 over root a plus 2, which means that a is equal, okay, to e 1 over root a plus 2. Okay, and that's going to be the final answer as required there. So that's quite a long question. So let's quickly go over how we did that. Right, the first thing we did was we kind of changed it up a bit and we used substitution. We used substitution first, and that's just to make things easier for us later down the line. Okay, with that, we then used by parts. Okay, we used by parts, plugged in our bounds, our new bounds. Okay, and we found our integral. Okay, which we then plugged into here to equal 6. And after that, we simplified and we got to the answer that they wanted. Okay, and that's that. Alright guys, now for number B, we got the following question. Okay, it says verify by calculation that A lies between 9 and 11. Right, so how do we do that? How do we do that? Well, this is our formula, okay? A is equal to e to the power of 1 over a, root a, sorry, plus 2. So, we can say that, we can say consider f of a is equal to a minus e to the 1 over root a plus 2. Okay, brilliant. I can then say f of 9 is equal to 9 minus e to the 1 over root a, which is 3, plus 2. Right? What does that give us? Well, that gives us negative 1.31. Okay. If we do f of 11 now, we get 11 minus e to the 1 over root 11 plus 2, which equals 1.01. And so we can say that as f of 9 is smaller than 0 and f of 11 is greater than 0, right? That demonstrates that a lies between these 2 points, okay? Because there is a change of sign, right? So we say therefore 9 to 11, and A is lying in between these. Alright, now for number C, okay, it's a classic iterative formula question, right? And I want us to determine a correct 2 decimal places. Okay, so very simple. There's not really much need to calculate each one. Well, you do obviously in the exam, but just for demonstration purposes, I've done it before. So I'm just going to go through it quick. We've got a n plus 1, okay, is equal to e over 1 over root a n plus 2, okay? We can say, well, a1 is going to equal what? Let's let a1 equal 10. And I've done that because we know it lies in between 9 and 11, right? And so 10 is the middle ground. Now if we use a1 is equal to 10, so therefore plugging that in, back in, come to my calculations, get 10.1374, which leads us to the following 1156. Okay, we plug this back in. Okay, plug it back in. Plug it back in. Keep it going. Okay, and our iterations have kind of curved over, right? They've stopped. So therefore we got 8 is equal to 10.1185. Perfect. Right, and that's the final answer to that question. Very simple, classic iteration question. This is a case of starting with one, a sensible estimate, which is what we got, plugging it in, and then just replugging. Alrighty guys, so for number 9, we've got a vector equation. Okay, so we get into the vectors part of the paper. It says we've got two lines L and M. Okay, with the following equations: 3, 2, 5, right, plus S, 4, negative 1, 3, right, and this line here. It wants us to show that they're perpendicular, and the way we show that they're perpendicular is through a understanding of the direction vectors and how they interact with each other. So the vector, okay, along L, okay, which is the first one, it says respectively, okay, that's 4 minus 1, let me just do like this, 4 minus 1, 3, right, vector along M, that's minus 1, 2, 2, right? So, in fact, let's give these names. Got 4, negative 1, 3, negative 1, 2, 2, right? So, for these to be perpendicular, okay, the dot product of A and B has to equal 0. So, if we work out the dot product here, 4 times negative 1, negative 4, minus 2 plus 6, right? So, minus 4 minus 2 plus 6 equals 0. Okay, so therefore A is perpendicular to B, okay? And that's all you need to do. We've shown it with the direction vectors, so therefore L is perpendicular to M. Now this type of question is a classic. It says that to show that L and M intersect, right? And it wants us to state the position vector of the point of intersection. So if we say this, let's jot down these two vectors, right? L and M. So 3, 2, 5. Okay. Plus S becomes 4, negative 1, 3. Perfect. Okay, what was that for? That's for R. Right? And we've also got, L. And then M is given as 1 minus 1 minus 2 plus t of minus 1, 2, 2. Okay. And what we're going to do here is we're going to set up 3 simultaneous equations. Okay. So it goes like this: 3 plus 4s is equal to 1 minus t. Okay. So 3 plus 4s is equal to 1 minus t. That's our first equation. The next one, 2 plus s, so 2 minus s is equal to minus 1 plus 2t. Right, so 2 minus s is equal to minus 1 plus 2t. Next, 5 plus 3s is equal to minus 2 plus 2t. Right? So 5 plus 3s is equal to minus 2 plus 2t. Brilliant. Brilliant. So, if we're equating these now, we can say, well, 2 minus 3, right, we can say what? Well, what's that going to equal? Well, we're going to get minus 3. Okay. Minus 3, minus s, minus 3, minus 4s. Okay. And that's going to equal minus 3. No, 1, sorry. Minus 1 plus 2, right? And from there, we know that find minus 4s then is going to equal 4, which means that s is going to be equal minus 1. Brilliant. So from 2 now, from 2, we know that 2 minus 1 is equal to minus 1 plus 2t. Right? So therefore, it gives us 3, add 1, so 2t equals 4. So t equals 2. Right? So we've got s and we've got t. Right? So plug in into 1. 3 plus 4 times s. 3 plus 4 times negative 1. It's going to give us, negative 1. And 1 minus t is equal to negative 1. Right? Brilliant. That makes sense. Alright. And looking in here, okay, 2. If you look here, 2 minus 1 equals minus 1 plus 2 times t. Right, 3 equals 3, yes. Right, and then plug in 3. 5 plus 3 minus 1 is going to equal minus 2 plus 2 plus 2. So 2 equals 2. Okay, so therefore all three equations are satisfied. Okay, now if all three equations are satisfied, therefore, what can we say? Right. We now need to find the position vector. Therefore, okay, 3. We've got minus 1. Then it was 3. Okay, and 2. Okay, because minus 1. Okay, and this one gave us 3. This one gave us 2. And that's going to be the final answer to that question. Alright guys, so the question now is, show that the length of the perpendicular from the origin to the line is 1/3 times root 5, right? So the way to think about this, okay, is we're using the line M. Okay, so what is M? Well, M, this is one of the classic questions that comes up all the time. So M is 1 minus 1 minus 2. Okay, and we plus t minus 1, 2, 2. Okay, brilliant. Now, perpendicular from the origin. So we're looking for a generic point. Okay, so we've got M here. We're looking for a generic point. Where we can connect. Okay. We're looking for the length of this. Right? And the way to think about it now is to say, well, listen, fine. This line, this generic point, is going to intersect here, okay? And it's going to be classed as r is equal to 1 minus t, negative 1 plus 2t, negative 2 plus 2t. Okay, and we don't know where it lands yet, which is why it's generic. That's the whole point. That's what makes it generic, because we don't know what the t is. Okay, so it could be down here where this happens, it could be up here. We don't know yet, which is why we've just made it generic. Now, what we do know is it's perpendicular. So if it's perpendicular, that must mean the dot product of the direction vectors must equal 0. Okay. Therefore, what is our direction vector? Well, this here is our direction vector, right? Negative 1, 2, and 2. So therefore, I can say, well, 1 minus t, let me just copy and paste this one. Right, 1 minus t, negative 1 plus 2t, negative 2 plus 2t. That, okay, times negative 1 times 2 times 2 equals what? Negative 1 minus t plus 2, negative 1 plus 2t, plus 2, negative 2 plus 2t. Okay, After we simplify this out, we get negative 1 plus t minus 2 plus 4t minus 4 plus 4t equals 0. Therefore, 9t minus 7 equals 0. So t is therefore equal to 7 over 9. Okay, very important. We've got t is equaling to 7 over 9. So if we've got that, that implies that, okay, let's say we got the point P here. Right. Oh, sorry, never mind. Our direction vector, right? So we can say this is our origin. Okay, yeah, let's do that. OP, right? We can therefore say, well, if we plug t equals 7 over 9 in, we can say that OP is equal to 2 over 9, 5 over 9, negative 4 over 9. Okay, that's the vector. And as a result, the problem now becomes this. We know what OP is. Okay, origin, right? The origin's P. We just need to find the length. The way we find length, we use magnitude. Okay, so length OP 2 over 9 squared plus 5 over 9 squared plus minus 4 over 9 squared. Okay, tap that into calculator. What you're going to get is root 5, right, over 3. That's going to be your final answer. So just as a quick recap, right? Quick recap here. We got a line M, we got O, okay, and a line from the origin to M hits at P, okay, and this is how we represent that generically. We know it's perpendicular, so therefore the dot product must equal 0, and if it equals 0, we get t equals 7 over 9, okay, so we then find these values, we then find the length, which gives us root 5 over 3. Alright guys, for number 10, it says that the complex number 1 plus 2i is denoted by u. Okay? And it has this polynomial where a and b are real, denoted by p of x. Okay, and it's given that u is a root of the equation p of x equals 0. Okay, and just from here, it just wants us to find the values of a and b. Brilliant. Brilliant. So, how are we going about doing this? Well, I can say this. As p of 1 plus 2i equals 0. And why have I said that? Because u is a root. Okay. U is a root. We can say that 2 times 1 plus 2i to the power 3 plus a 1 plus 2i squared plus 4 1 plus 2i plus b equals 0. If we simplify this out, we get 2, 1, 1, let's see, 1 plus 6i minus 12 minus 8i plus a 1 plus 4i minus 4 plus 4 plus 8i plus b equals 0. Therefore, 2 negative 11 minus 2i plus a times minus 3 plus 4i, okay, and then plus 4 plus 8i plus b equals 0. What does that then give us? Negative 22 minus 4i minus 3a plus 4ai plus 4 plus 8i plus b equals 0, right? Which then corresponds to the following. Negative 18 minus 3a plus b plus I plus 4 plus 4a equals 0. Okay. Brilliant. Brilliant. So if this equals 0, that's the same thing as 0 plus 0i, right? So therefore we're going to equate both of these to 0, because that's what they equal. So negative 18 minus 3a plus b equals 0. 4 plus 4a equals 0. A equals minus 1. And 18, using this knowledge of a equals minus 1, 18 plus 3 plus b equals 0. So b is going to equal 15. Okay? And that's going to be your final answers here. Brilliant. So, remember, we've got 1 plus 2i denoted by u. Okay, and this is a polynomial. It's given that u is a root of this equation. Right? So, we know that p of 1 plus 2i is going to equal 0. Okay? Therefore, as we've got that, you've got that value for u, you can then plug it back in here. Sorry, plug it in for x here. Okay, equals 0. Plug 1 plus 2i in, and equate it to 0. And we get these values for a and b. Alright, now over here it says state a second complex root of this equation. Well, what was our first complex root? The first one was 1 plus 2i. Okay, and the second root is going to be the conjugate. Okay, in all cases, it's going to be the conjugate. So if the first root was 1 plus 2i, therefore it's going to equal 1 minus 2i in this context. Alright guys, for number C now, okay, it wants us to find the real factors of p of x, right? So the way you need to think about this is like this, right? We know what our roots are. Okay, it's 1 plus 2i, right? And 1 minus 2i. So therefore, we have our roots. So we know the start here. Right, remember p of x here is the power of 3, okay? But we know this is a factor because we know 1 plus 2i and 1 minus 2i are roots, right? And therefore, with that in mind, we can say that, you know, combining these together, that's all one big factor. We just need to find the next polynomial, which is going to allow us to factorize it completely. So if we expand this out, we get x squared minus 1 minus 2ix minus 1 plus 2ix plus 1 plus 4. Okay, brilliant, you've got that. Now, with that in mind, if we expand this out even further, so therefore x squared minus 2x plus 5 is also a factor, right? So this is the same as this, okay, and this is our factor here. Now what's important is to find the next factor here. We can use long division. So I could say that there's a few ways to do it, but this is one way. You could equate coefficients, but I feel I'd use long division here because it's not typically used that often, but it could help simplify things. So x squared minus 2x plus 5, and we're going into what? Well, 2x cubed, right, minus x squared plus 4x plus 15. Okay, and then now you can see how everything links together, right? And why the different videos on this channel, they all link together to different sections, and within the paper they come into like small little bits, right? So you might not get algebra questions per se, but they will crop in. So simple, we just use long division. So you get 2x cubed here because x squared goes in here, 2x times, okay, times out 2x cubed, okay, minus 4x squared, okay, plus 10x, right? Brilliant. Apply that, and then if we jot this down, we get 3x squared minus 6x plus 15 on the bottom. Okay, go x squared coming here 3 times. Right, goes in 3 times. And so if we multiply that back out, it's 3x squared minus 6x plus 15. Oh look, no remainder. So therefore 2x plus 3 is also a factor. Okay, so therefore p of x is going to equal 2x plus 3 x squared minus 2x plus 5. Alright guys, now for number D, it says on a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying these inequalities. Z minus u is smaller than or equal to root 5, and the argument of z is smaller than or equal to pi over 4. Right? So here's what I'm going to do. Draw this here. Draw this one here as well. Okay, draw a circle. Okay, and remember what u is. U, okay, our radius here is going to equal 1 plus 2i. Okay. Right, now this radius must be smaller than root 5. Okay, It's important to know. We'll get to that in a second. But the other condition needs to be satisfied is argz being smaller than or equal to pi over 4. So we got that here, like that. Cool. And it's just a case of shading in now. Okay. So by shading that in, okay, we've represented this point. So this is argz. We've got argz. Smaller than pi over 4. Okay, we've also got z minus 1 plus 2i, smaller than root 5. Okay, in terms of the least value of the imaginary value of z, well, that would lie around here, right? Imaginary value, so it's all along this axis, vertical. Okay, so that's going to be P might as well sketch that on as well. Point P, and that's going to equal 1. Okay, so again, x value here 1, and it's going to be equal to 2 minus root 5 on the imaginary axis. Okay, and that's going to be your final answer to the question.